everyone. We want to solve the following differential equation using a power series. So in order to solve this one, we start by making the following assumption. That y is of this form, centered at 0 in the first derivative and the second derivative. When I substitute those back into the original differential equation, I get the following equation. In order to solve this, we need to condense it into one power series starting at the same place. Well, we have a problem that these all start at different places and I have different exponents. So the first thing we'll do is address the fact that this starts at 2, this starts at 1, and this starts at 0. So if we shift this in order to make it start at 0, then all of these need to be shifted 2 units. So in order to do that, I make that into n plus 2, n plus 1, a, n plus 2, and this becomes x to the n. Quick check. When n is 2, we'd have 2 times 1, a2x to the 0. Now at n equals 0, we have 2 times 1, a2x to the 0. So we did it correctly. Now we'll go ahead and distribute the x into there. And that will give us x to the n. And then in the last one, we'll simply multiply the 2. There's the infinity there. So 2an x to the n. Now if you notice, right now the very first term here is going to be an x to the 0th. The very first term on this one is going to be an x to the first power. And the very first term on this one is going to be x to the 0th. Since I can't do anything with this one, we'll go ahead and write down the first 2 terms of these power series right here. Now this gives us the following when we expand it. And notice now that when we ran off the first term here and the first term here, both of these series now start at 1. So they start at 1, x to the n. Start at 1, x to the n, 1, x to the n. So I will add the constant terms in front and then put everything together into one series by adding the coefficients times x to the n. Since it is all equal to 0, this means we have a polynomial that is equal to 0. Since x cannot identically be equal to 0, this has to be true for all real numbers x, it's the coefficients that must equate to 0. Meaning that this coefficient must be 0 and this entire coefficient here must be 0. When I do that, this whole thing equals 0. If I solve for the a n plus 2 term, it gives us the following recursion that we're going to analyze in a moment to figure out the coefficients of our answer.